A muddy lakebed comes into view from above. A trackway of human footprints stretches out in an almost straight line. The footprints are deep, slightly asymmetrical. Right next to them, a few tiny footprints suddenly appear. The child has been put down. After a short distance, the child's footprints vanish. The adult's stride shifts shape again. The child has been picked up. This pattern repeats. Carry, put down, let them walk, carry again. If just 1.5 kilometers required this constant switching between walking and carrying, how did children survive migrations hundreds of times longer? This trackway doesn't record a migration, but it preserves the principle that made any movement with young children possible. That is the ability to share the walk and transfer the load from one body to another. We often ask the wrong question. How far can a child walk in a single day? The right questions are, how old are the children? What kind of terrain are they walking on? Who carries them when they get tired? Who carries the gear for the person holding the child? Where is the next water source? And does the new camp need to be built before it gets dark or freezing cold? Is this trip a short residential move or part of a multi-generational range expansion? Moving a camp is a massive undertaking in terms of energy, time, and logistics. The distance of each leg is a calculated decision, not just the limit of maximum physical endurance. A long, straight line on a map actually breaks down into campsites, watering holes, resting spots, and gathering places. Once you break a journey down into multiple stages, children surviving long migrations is no longer a miracle of endurance. It becomes a sorting problem. Who walks, who is carried, and who steps up to help others? To solve this problem, we need to look at each age group. For nursing infants, the food travels with the caregiver's body. The infant doesn't need a separate food pouch, but they must stay close enough to nurse frequently. Data from the BaYaka community shows that mothers can carry their infants during foraging trips, nursing intermittently between activities. Carrying a child makes the trip take longer, but it doesn't reduce the total distance covered or the net amount of food brought back. Next are toddlers. They don't entirely walk on their own, but they aren't fully carried either. They can walk on flat stretches, be carried over mud or cliffs, and rest when adults adjust their loads. For middle childhood kids, shorter strides don't necessarily slow the whole group down. They can maintain a pace close to adults by taking quicker steps or walking at a speed that remains relatively energy efficient. Even so, heat, steep terrain, or long distances can still drain them quickly. Finally, adolescents. They are practically a full adult labor force. They can carry loads, guide younger kids, help fetch water, memorize routes, and prep resting areas. This perspective shatters some deeply rooted misconceptions. Children weren't just a passive burden. They participated in learning skills, watching siblings, and contributing small amounts of food from an early age. Mothers didn't bear the entire cost of moving alone. In many societies, direct childcare was distributed among siblings, fathers, grandparents, and sometimes people with no blood relation. Adults didn't just set a fixed pace and force the kids to keep up. A group's pace is a negotiated settlement between multiple bodies. And of course, not every child survived. Archaeology easily shows us the footprints of those who finished the journey, but it rarely records all the children who died along the way or the expansions that completely failed. When each age group plays a different role, the secret isn't finding someone strong enough to carry it all. It is building a system where no one has to carry the exact same load for the entire journey. That system operates through 6 mechanical layers. The first layer is breaking a long route down into multiple residential moves. A range expansion of hundreds of kilometers might be built from countless short moves, taking a few hours or a day, interspersed with stops lasting weeks, moments of splitting up and then regrouping. No child needed to cross a whole continent in a single trip. Some children were born right in the middle of a journey that the group simply called daily life. The second layer is carrying the members who cannot maintain the pace. This solves the problems of speed, dangerous terrain, and positional control. but it creates a new load. The carrier burns more energy, loses the flexibility of their hands, struggles to carry tools, and has to stop frequently. That is why they needed the third layer, rotating the carrier and the load. When one person carries the child, another can carry their bag. A third hauls the firewood. An older child takes the lightweight gear, and someone else walks ahead to scout the trail. After a while, these roles switch. The fourth layer is ensuring food and water appear along the route. The group doesn't just calculate the distance to the final destination. They have to know where the next water source is, where easy-to-gather food might be, where the closest shade is, and if they can turn back if a child suddenly falls ill. A longer route with more recovery stops is always safer than a straight line. The fifth layer is adjusting the pace instead of forcing absolute synchronization. Bringing a child along might make the trip take longer. The viable mechanism is to walk slower, stay longer at spots with food, stop to nurse, swap carriers, and reduce multitasking. The sixth layer is gradually transitioning the child from a dependent into a supporter. As they age, they walk longer stretches, carry their own gear, watch their younger siblings, forage for sweet fruits, memorize watering holes, and learn to spot danger. Their productivity increases gradually over time rather than suddenly appearing in adulthood. All of these mechanical layers serve the final one, preserving a mixed-age community. A group of perfectly healthy adults can travel at optimal speed on an expedition. But to expand a population and turn a new land into a home, the group needs people who can give birth, children who survive to adulthood, food providers, caregivers, and future mating opportunities. The mechanics show that a system like this can work, but direct evidence only preserves fragile moments. Someone carrying a child, a group walking at the same speed, and a modern community sharing the cost of care. The first piece of evidence takes us back to that ancient lakebed at White Sands, New Mexico. A late Pleistocene trackway stretching about 1.5 kilometers preserves the continuous footprints of a larger individual, with an asymmetrical stride perfectly consistent with carrying a load. Mid-journey, the footprints of a small child appear for a few sections, then vanish as the larger footprints continue. While we don't know who the carrier was, their relationship to the child, or if this was an emergency, the most logical interpretation is that an adult or adolescent carried a young child for most of the way, occasionally putting them down to walk a few steps before picking them back up. Transporting a child isn't a binary choice between letting them walk or carrying them completely. It is a shifting system that adapts to terrain, speed, and fatigue. In the footprint record, the child disappears. On the actual journey, their weight just changed location. But not every child needs to be carried. At Ngare Sero in Tanzania, over 400 ancient footprints capture a moment when a group moved in the same direction at roughly the same speed. Based on estimates, this group included 14 adult women, 2 men, and 1 immature individual. While estimating age and sex from footprint size always carries a margin of error, this shows that immature individuals didn't necessarily stay behind at camp or break the group's formation. An older child or adolescent can absolutely fall into the walking rhythm of adults. Footprints found at the La Roselle site also support the fact that children were present right at the daily activity surfaces. Footprints count the people who touch the ground. They miss everyone being carried. So does bringing children along bring the subsistence system to a halt? GPS and heart rate tracking data from nursing BaYaka mothers show that children accompany them on nearly 60% of foraging trips. The presence of a child makes the trip take longer, but it doesn't cause a drop in the total distance covered, the energy expended, or the net food gathered. They balance this by extending the time, having group members help hold the child or carry the basket, and getting support from older children who come along. They don't eliminate the cost of the child. They just ensure that the cost doesn't rest permanently on a single body. This support network is an invisible layer of survival armor. In a comparative study of 3 small-scale societies, mothers provided an average of 57% of direct care for infants. The remaining 43% came from others, with siblings stepping up as a massive support force. This is alloparenting, childcare provided by siblings, relatives, or other camp members. A child sits in the middle of a network of a mother, father, siblings, relatives, and even non-relatives. If the primary caregiver gets injured, needs to fetch water, or has to build a shelter, the child doesn't lose their entire protection system. Older children can guide the little ones, carry them for short distances, share food, and sound the alarm if someone falls behind. Children survive not just because one person never leaves their side. They survive because there is always the possibility of someone else stepping in. And that network is the mandatory equation for colonization. Demographic models of the settlement of Sahul show that a small group of explorers could not create a sustainable population. They needed a relatively large founding population, or they had to split into multiple successive waves spanning centuries. Children weren't just passengers brought to a new land. They were the ones who would learn the terrain, survive those first harsh seasons, create the next generation, and turn a journey into a permanent residence. Explorers can reach a new land. Only generations can settle it. Footprints show children being carried, and older kids walking on their own. Data from living people shows that care, food, and loads can be shared. Population models show why these mechanisms matter. Without surviving children, a migration is just a trip, not the expansion of a community. The presence of children radically changes every mobility decision. A group without small children can prioritize carrying tools, weapons, food, and fuel. But a group with children must dedicate carrying capacity to the child themselves, warming materials, spare water, and sleeping gear. Every kilogram dedicated to a child is a kilogram not dedicated to something else. Children change the route. The shortest path might be a steep cliff with no water and no shade. A longer route with multiple stops is significantly safer for nursing mothers, toddlers, and people carrying heavy loads. Children change the departure and arrival times, forcing the group to avoid peak heat, take longer breaks, and arrive early enough to build a shelter. A journey designed for healthy adults has a much smaller margin of error when children are involved. The real twist happens when those children get old enough. They actually make the group more flexible. Suddenly, the group has extra babysitters, extra hands to gather small food items, extra people to carry light gear, and extra memories to memorize the route. Migrations are essentially moving schools. Children learn which watering holes exist seasonally, what plants signal moist soil, and how to read the tracks around them. A territorial expansion can take years, even generations. A child who sets off in an adult's arms might be fully grown before the community reaches the new edge of their range. They don't just move across a landscape, they become the memory keepers of the terrain their parents once called new. This system explains why range expansion with children can succeed. But since most of the evidence comes from a handful of footprints and recent societies, the gap between these two types of data needs to be kept clear. The White Sands trackway shows a journey with a carried child, but it doesn't prove it was a residential move. The carrier might have been foraging, visiting another group, or dealing with an emergency. Footprints don't record the people being carried, so a surface with few child footprints doesn't automatically equal a low percentage of children in the community. Modern hunter-gatherer groups like the BaYaka or Hadza have their own distinct social histories. They are not carbon copies of the Paleolithic. Their data proves a mechanism can work. It doesn't prove an ancient group used that exact mechanism. Even walking speed experiments on children are conducted on healthy individuals, excluding malnutrition, extreme temperatures, rocky terrain, or the burden of carrying heavy loads for consecutive days. Cooperative care doesn't guarantee every child is treated equally either, as it depends on kinship, resources, and internal conflicts. And crucially, successful communities leave behind descendants and archaeological sites, while the groups that lost their children or vanished entirely leave too few clues behind. The evidence shows humans can carry children, share childcare, and move in mixed age groups. It does not allow us to reconstruct a universal migration process or a specific child survival rate. While we can't know every route, the organizing principle remains deeply familiar. A family journey succeeds when the pace and reserves are built around the person with the smallest margin for recovery. This principle is glaringly obvious in the modern world. A group of adults can calculate a trip using kilometers, speed, and time to destination. But a family with small children has to add in meal times, nap schedules, heat, water, carrying capacity, and backup plans for when a child gets sick. These factors don't make the trip disorganized, they create a different type of organization. One with more stops, a flexible pace, shared roles, and a much larger safety margin. Modern infrastructure usually isn't judged by whether the fittest person can use it, but by whether a toddler, an injured person, or someone carrying a heavy load can get through. The exact same logic applies to ancient journeys. A watering hole is only useful if the whole group can reach it. A steep incline is only viable if the smallest child can be brought over it. And a new camp is only a success if the caregivers still have enough energy left to build a shelter. So when we return to the muddy footprint track from the beginning, the answer isn't about how far the child managed to walk. It is about how the entire group adapted every time those small feet couldn't take another step. Back to White Sands. The child is put down. They take a few steps. They slip or slow down. The adult leans over. The child is picked up. The small footprints vanish, and the deep, heavy stride continues. If we widen the lens to an entire hypothetical group, we would see someone carrying a child, someone else carrying their gear, an older child walking independently, an adolescent holding a baby, a scout checking the water ahead, and others ready to build camp when the group arrives. Children survived long migrations because most journeys were broken down into multiple short stages. Infants were carried and nursed on the move. Caregiving, loads, and food were distributed across multiple people, while older children walked on their own, supported their younger siblings, and gradually joined the group's workforce. Certainly not every child survived, and no single universal technique saved them all. Terrain, climate, health, food availability, social dynamics, and pure luck made the outcome of every journey completely different. The history of human expansions is usually told with giant arrows on a map, with distances, dates, and ecological corridors. But those arrows never show us the moment someone switched arms to carry a heavier child, the moment a whole group stopped because a toddler was thirsty, the moment an older sister carried her sibling on her back, or the moment a child memorized a route so they could lead another group years later. Dependent children shaped the group's logistics. Long journeys were survived by turning them into many short days. Human migrations succeeded not when children endured an adult pace, but when the whole group learned to move at a human pace. A long arrow on a map slowly dissolves into dozens of tiny campsites. At each camp, the child grows a little bit more. And at the final destination, the child who once struggled to take their first steps has now become the one steadily carrying another child in their arms.